Hi, my name is Sven Gedicke from the University of Bonn, and in this talk I will present a joint project on lightweight algorithms for an in-field quality assessment in agricultural science. This project is part of FAIRagro, which is an initiative that builds a fair research data management system for the agrosystems research community. One central element is the development of the FAIRagro portal, which connects available data repositories, making them findable and also accessible. Also, different services are developed to enhance the interoperability and reusability of the data. And one of such services is a data quality assessment service, which is our focus of work. To motivate our quality assessment approach, let's take a deeper look in the current data collection workflow in agricultural science. So typically, scientists gather data in the field and analyze it later in the office. Possible data issues, such as those caused by faulty sensor calibrations or weather conditions, are only revealed at this point. And to correct these issues, the scientists must cleanse the data in a post-processing step or even re-record the measurement at a later point in time. And now, to overcome this inefficient workflow, we are developing an interactive interface for an in-field quality control. So our goal is to support scientists during data collection by identifying quality issues already in the field, allowing them to address potential problems immediately. Additionally, by integrating the quality assessment into the data collection process, we argue that we can lower the barrier to uploading quality information with the data. So our approach enables the automatic generation of quality-related metadata, which can then be incorporated and published alongside the data. And with this, the reusability of the data is improved. Generally, our interface is intended to intuitively provide a data collector information on the currently recorded data. One common issue here is when developing such an interface, a stable internet connection is not always guaranteed in the field. This is why we are concentrating on client-side processing, so we don't require any server communication. For this, we need lightweight algorithms that are executable on the mobile device itself, which can have a limited memory capacity. And also to provide compatibility across multiple different operating systems, our approach is browser-based. So no specialized software needs to be downloaded. And also an advantage is that the data with our client-side processing remains local, meaning that we can enhance privacy with this. While the main motivation for our quality assessment interface is the in-field quality control, it can of course also be used at home to assess the quality of an already published dataset. From a methodological perspective, our current focus lies on time series data, since a large part of scientific studies in agriculture relies on such data. Algorithmically, we follow a sliding window technique, which enables memory-efficient computations that are essential when using mobile devices that can have a limited memory capacity. At the current state of development, our interface implements summary statistics as well as state-of-the-art algorithms for outlier analysis and also data clustering. Also, we follow a modular design, meaning that we can flexibly combine our different algorithms in a building block manner. And now, to have a better look and feel of our interface, I will show you now a short demo video. For this short demonstration, let's consider a desktop variant of our interface, and since we are not in the field, the use case that a scientist wants to assess the quality of an already published dataset. So this is our current interface, and first of all we need to select the dataset that we want to assess. Let's click on the selection button, and when selecting a file, we have a quick preview to check whether all columns are read correctly. Once we confirm the selection, we need to select some mandatory columns. One is for the chronological order. For this, let's take the timestamp here, and one is the data column that I want to evaluate. Here, we exemplarily choose a fluorescence value. Furthermore, we can optionally enable a division of our data, which makes sense in our example, since here we have fluorescence values for different combinations of crops, namely different bean and wheat types. The parameters on the right are optional, for example for an adaptation of k-order statistics, but default values are already given. So now we can run, for example, our statistics and outlier analysis, wait a short moment, And then we have visual results of some statistics like the mean, truncated means or extreme values, and also the outlier analysis. In both plots, I can now switch between the different crop combinations for a targeted assessment of my data. When thinking of the application during data collection, the data would be continuously fed into our interface, with the plots being incrementally built. Now, considering the status of our interface, I want to point out that we are at an early stage of the development process. In particular, we consider a bottom-up strategy in which we started with time series as a fundamental data type. Throughout the further development, we will extend to other data types such as geospatial data and successively add suitable state-of-the-art algorithms. We will further focus on more intuitive visualizations and will continuously include the opinions of domain experts. Also, we will consider the perspective of human-computer interaction to ensure that our interface is user-friendly. We aim to strike a balance between automation, which enhances convenience, and user input, which remains essential as the user is typically also the data expert. As future prospects, we see large potential in integrating our interface in established workflows, for example, such that use applications as the electronic field book. Here, our quality assessment could be a valuable addition, for example, as a modular library. However, one technical challenge here is the sensor communication, as currently measurements mostly remain within the sensor when collecting data. This is why I want to end my talk now with a call to the community for workflows that are tailored towards fair data. To make progress in this regard, mutual adoption on different sides is necessary here. And with this, I thank you for your attention.